First of all, thanks a lot to the organization because they are doing an amazing job. I think everyone agrees with that. So this talk is about monitoring and how monitoring is important to keep our systems running at all times and to prevent and identify problems before our customers report them. A quick note about myself. This is my website and my Twitter account, so you can reach me there for any sort of feedback. I will publish the slides there as well. And I've been working for the past 15 years, first in Italy, then in the UK, for several large enterprises. And I was lucky enough to be on amazing projects, very large-scale projects. So in my experience there, I learned a lot about scaling systems, and I learned the importance of good monitoring and reporting when things go bad. So we live in the big data age, and we have large and complex systems. The thing is, sometimes we do have some kind of failure, and any loss, any failure, no matter how short, can mean a serious loss for the business. And if we don't have monitoring hooks anywhere, everywhere in our application, sometimes it's very difficult to find where the problem is, especially if the architecture is complex and the platform is large. So observability is obviously a pretty critical feature. And as I said, you have to bake monitoring hooks into your application to get full visibility. Just having a system-level monitoring hooks is not enough, right? And even if you are logging and monitoring tons of events, if you're not looking at them, or you're not looking at them in the right way, they are quite useless, right? So good reporting makes all the difference. And I believe the vast majority of the monitoring dashboards and business intelligence tools in the past 20 years have completely missed the point. Because they focus on all sorts of things, but usually wrong things, like making things pretty rather than providing information. And I believe that a good monitoring dashboard should be designed for humans. And so in order to design a good dashboard, we should first understand how our brain is processing information, how we think, and how we make decisions. This is the book that inspired this talk. It's an incredible book. Daniel Kahneman won the Nobel Prize for behavioral economics. It's really, really great. I suggest to buy and read it. It's wonderful. And I believe that most of the content that is discussed in this book also applies to even monitoring. A lot of things, but even monitoring. So the book is a tale of two systems. Our brain operates in two different modes. The first mode, also called System 1, is what we usually refer to as intuition, instinct, gut feeling. So it's fast, it operates almost effortlessly, it's just quick. If I ask you how the result of 2 + 2, you know, it's 4. You don't even have to think. Conversely, the other system, the other way the brain operates, this is the visual cortex, the cortex, so the outer part of the brain, requires a lot more effort. So it's a constant process of coming to a conclusion based on processing of all the evidence, right? And this is a conscious activity. It's not something that we just have the answers for. So if, for instance, I ask you to resolve that operation, then I bet most of you will either give up before even trying, or will actually spend a lot of energy to come up with the result, right? And attention is not just a matter of a brain activity. It has repercussions in the whole body. So when we engage our attention, our muscles contract, our pupils dilate, our blood pressure rises, so how our the blood pressure increases, the heart rate increases. So given this effort, the brain has a very limited capacity for attention. So we need to preserve this limited capacity for the moments when we really need to use it, right? So for this reason, I believe that a good monitoring dashboard should rely on system one, so the intuition, the instinct. So we should make everything we can in designing our dashboards so we can appeal to our intuition without engage the more effortful activity constantly during the day. System two is always there. It keeps monitoring everything we think about, we process, and is always in the background, ready to jump in when there is something wrong. So the goal of system one, the instinct, is to model normality. So it creates a model of an environment under normal conditions. Because once you have this image of what's normal, then it's easier to be surprised by anomalies, right? And that's where system two, the attention, comes in, right? Similarly, for monitoring dashboards, they should be there in the background, monitoring normal conditions, and they should be there just as a quick reference. With a quick glance, we should immediately spot whether everything is fine or not. Alerts, on the other hand, are there to trigger our attention, to switch on our attention, right? So this is our monitoring dashboard. It's a wall of graphs, and we have everything in there under control. And we have a siren when there is an event that triggers. So we are visually and also with the audio, we can hear when something is wrong. So we can immediately turn on the full attention. So there are ways we can do a better job at attracting the attention only when we require the attention. And often we use color and images in a bad way. We overuse them. Take this graph. You have to read every single column. What about removing the color and only using color for bad conditions? This way, you can immediately understand what's going on. You can immediately identify the bad points. Another mistake we often make is we add a lot of data. So we cram dashboards with a lot of text, a lot of information. And I think a good example of this is this very old infographic. This is an infographic representing the march of Napoleon's army to Moscow. And it was made 150 years ago. And I think this is a masterpiece of information density. If you look at the light brown line there, it shows the progression across Russia of the army as it approaches Moscow. And the size of that line represents the size of the army. So you can see how it shrinks on the way to Moscow. And the black line is the way back. So you see a lot of that's there as well. And if you look at the bottom, there are other numbers there. There is a graph showing the temperature. So, of course, it was a harsh winter, and cold played the part it was not a battle. The war was lost because of the cold mostly, right? So it combines at least 5 different facets, different ways, different pieces of information all together in one graph. And it's a masterpiece for that reason. Except for you have to spend 15 minutes to read all the descriptions, all the text, in order to make sense of it. So for this reason, I think this is a perfect example of what not to do in a monitoring dashboard. Because monitoring dashboards should be immediate. You shouldn't need to spend 15 minutes to understand them. One thing that the previous graph was good for is that it gave numbers a visual shape. So take that table. I bet most of you can, at most, remember 4 numbers at any given point in time, if you're really good with your memory. But give it a visual shape, and you can just take a snapshot with your visual cortex, and you remember the shape of the lines, and you can remember like 12 values at once. Dashboards are not analysis tools. We usually cram them with data, and I often see dashboards like these. They combine all sorts of things, even not related. We have this fear of leaving a spot empty. And every time I see something like this, it reminds me of something like this. a cockpit of a plane, and I'm overwhelmed with a sense of doom and despair because I can't possibly understand what's going on. I don't know how to pilot, to drive a plane. So I'm really, really overwhelmed, and as a result, it's pretty useless. It contains a lot of information, but I can't read it. So we think we need data, a lot of it. We think we have to analyze things. Reality is, monitoring dashboards are not meant for that. If we are really honest, monitor dashboards are there for one reason, to answer one question. Is everything all right? Are there any issues with the system? No? Good. See you later. Right? So we really need to think about dashboards as something that should be there in background for a quick check, but they should not engage our attention all the time. As I said, our attention is limited. We have a limited capacity. So complex dashboards create a lot of fatigue. They deplete our limited capacity, right? And to conserve attention, our brain plays all sorts of tricks. Our brain is very lazy. By default, it will try and conserve energy. So there are a lot of things that the brain does. So take this question, for instance. It's a simple problem, but if we are tired or we don't really care, all we can see from that question, that problem is 555, 100, 100, and we think the answer, the intuitive answer is 100, right? 555, 100, 100, 100, symmetry, all is good. So of course, System 2 can jump in and reject the intuitive answer. It can correct the mistake made by System 1. But sometimes it doesn't care. It will accept any answer given by System 1, no matter how approximate, no matter how incorrect, because it will think it's acceptable. So what happens here? We have our brain that, in case of a difficult task, it will swap out that difficult task for another one, which is similar, not the same, similar, which is easier to answer. So if I ask you right now, how happy are you with your life? It's a complex question. It depends on your health. It depends on the degree of satisfaction in your job. It depends on whether you are happy in a relationship. So it's a very complex question. So what we do is we swap out this question, how are you happy with your life, with an easier one, like, how do you feel right now? That's a much easier question to answer, but it's different, right? So our brain applies heuristics, right? It will swap out questions, difficult questions for easier ones. And we don't even realize this happens most of the time. So whenever I see a dashboard like this, my brain can decide what to do. It can either make effort, it can either use up some of the finite capacity for attention and trying to make a sense out of that dashboard and trying to understand what's going on. Or it can decide to swap out that difficult task for an easier one, like, how much do I like the person who created that dashboard, right? Our attention is lazy. If we are tired, or if the information is too subtle, we ignore it, right? Why don't we have dashboards like this? At a glance, we can tell everything is fine there. Everything is green. Or if we see a red spot, that's when we alert our attention, right? It's the same information, just displayed in a different way, which is intuitive. So in order to make sense to us, information also needs to be organized in a way to support meaning, by context, right? So we often organize information by the tool used to produce the data. So for instance, we have Cacti that is collecting data about our CPU, our memory, our bandwidth, and we show a dashboard with all those metrics collected by Cacti. We have another dashboard that is presenting all information collected by Xenos or Nagios, right? So it's easier for us, programmer, to create dashboards based on the tool that was used to generate the data. But what if you have a problem in your system? Suppose you have a feature that goes down or is not available. How does that relate to any of that data? You don't know. The link is missing. The context is missing. So it's much easier, much better to think about the consumer of the information. Think about the people who had to use the dashboards. So if you organize the same data by context, it's much easier to find all the information related to that feature in the same place, and then you can target your analysis without effort. Another mistake we make is we tend to embellish things just for the sake of the embellishment, and we don't give the information the importance it has. So we don't let information stand on its own. Example, speedometers. We love them, right? They are beautiful. They remind us of a cool car, a sports car, and they have like a 3D effect. They have a glass reflection. They have bouncing needle even, some of them. So what can we do to make them even better? We could add bacon, because everyone loves bacon, and that's the ultimate speedometer, right? So even if your customer is asking you to make those dashboards look pretty, refuse. Just present information in its simplest terms. If they still disagree, they still want embellishments, just overdo, like I did now. They will see the point, right? Another example of pointless embellishment is pie charts, and especially 3D pie charts. So why is that? Because, first of all, our brain is not very good at analyzing round shapes, so analyzing the size of round shapes is very difficult for us, especially if we use a 3D distortion that, you see, the light blue and dark blue areas actually have the same value, have the same size, but because of perspective, they look different, right? So we distort the data, we distort the meaning, we distort the value of the data just for the sake of embellishment. So we sacrifice accuracy for aesthetics. So anytime you feel tempted to use a pie chart, use a bar chart instead. It uses the same amount of screen estate. It's easy to compare the data and to sort it. And you can also overlay some information on this without making it look cluttered, right? So back to our friend, our brain. As I mentioned, our mind plays all sorts of tricks to conserve energy and to conserve attention. So let's learn one or two things about our brain. One thing we need to know is our brain is a machine to jump to conclusions. Even given very little evidence, our brain will make up the gaps, will fill the void left by gaps, and will complete the information that is not there. An example, can you read there? I bet most of you will read ABC, and then 12, 13, 14, right? Are you still sure? Is there no ambiguity at all in there? You see, so our brain will fill gaps and suppress all the ambiguity just to make sense of, to simplify its job, to preserve energy. And this is where we should be really careful when we design our dashboards, because if we only have one means of looking at our data, then it could be very deceiving. So take this, for instance. This is a graph of the traffic on our platform. And at one point in time, so we have different nodes, the different colors are traffic on each node. At one point in time, our graph started collapsing. And the immediate reaction was, oh crap, we are losing data. Right? Because that's the only obvious conclusion you can get from the graph. Luckily for us, we had other graphs as well. So we looked at other metrics we had. We looked at bandwidth, we looked at the load on the other systems that were involved with the communication, and everything else was fine. So later on, we discovered that the platform was absolutely fine all the time. But because of a reboot on the statistics server, the events, the metrics, or the monitoring events couldn't reach the statistics server. And we panicked for no reason. So this highlights the need for our brain to compare information coming from different sources and view the same information from different perspectives, because hopefully one of them will actually make sense. And we can compare different views over the same data by having this two-way matrix, for instance. So we have one view, the vertical columns, combined with the horizontal rows. And together we have two different ways of looking at the same information. So this is already a compact way to combine many views, right? I said earlier that our brain can fill the gaps when the information is not complete. I'll tell you more. Sometimes our brain doesn't need any information at all to jump to conclusions. So our biases are enough to jump to conclusions. I'll make an example. We have certain emotions when we think about certain languages, right? So if we compare C++ and Java, we have this image of C++ as something really hardcore, rock solid, performant. And Java evokes a different kind of emotions. Usually we think about garbage collection policies or null pointer exceptions that cause havoc to our system, right? So this is a strong association we have from the language that goes on to everything we build with those languages, right? So supposing we have a pipeline and we have two different components in that pipeline. And all we know is that at the end of the pipeline, something is wrong. We are not receiving data. And we know that the first component is written in C++, the second one is written in Java. I bet most of us will blame the Java component with no evidence at all, just because we have this bias against Java, right? So we should look at metrics first. We shouldn't jump to conclusions without looking at metrics. We fail to look at evidence first. So as I just showed you, our brain is really good at creating these kind of associations. And I'm going to prove this with another example. In the next slide, I'm going to show you a word which is missing one letter. And I want you to say the word, the complete word, aloud as soon as you can think of it. OK? Missing letter in a word, you say which word it is. You ready? Most of you will say soap. There are at least other 3 words that are good, like slap, snap, swap. So what happened there? Well, the thing is, I tricked you. Before the experiment, I showed you a slide with another word, which was wash, right? So I primed your brain into thinking to things related to washing. And you thought about soap as the choice out of the 4 that had the strongest correlation with the previous word. So our brain automatically selected that association and ignored all the other options, right? So we should really rely on this great ability of our brain to recognize patterns and make associations. So we should rely on conventions like green, good, red, bad, colors, or shapes, or sounds. They also evoke different emotions, right? And as an example of a shape that evokes an emotion, take this graph. When we see our screen filled with a graph like this, with very spiky and very tall lines, we get scared. We think everything is on fire, right? So we get scared, we panic. And most of the times, this is unjustified, completely unjustified. Why? Well, because we simply forgot to normalize the data. And if we did, it might have shown a very different image. So this image is probably an indicator that you have plenty of capacity in the system, everything is fine. So you engaged your full attention by panicking early on, you wasted some of your finite capacity for attention without any need. So we've seen some of the tricks that our mind plays to conserve attention, to conserve energy. So I'm going to show on a more practical note some examples on how you can use this information in a real-time platform. First of all, it's important to have an arsenal of different tools to monitor things. And there are plenty to choose from. I don't even want to mention specific ones because there are really lots and lots to choose from. But I just want to mention that sometimes unconventional alerting tools can really, really play nicely. As I showed you earlier, we have a siren to alert us. And this is very unconventional, but it's really effective. It's really easy to get started. There are even VMs with all the tools pre-installed, prepackaged, ready to be used. So you just spin up a Vagrant machine and you're good to go. Okay? And there are plenty of articles on the internet. I just make one example to show how easy it is to collect those metrics. At work, we use StatsD and Graphite a lot. StatsD is a Node.js daemon that will listen for messages and will send them over UDP. And we'll then pass them to another tool which can display, aggregate, collect, and display the metrics, which is Graphite. For instance, this is a PHP script. There are bindings for any language. You can see there we have some kind of event processing platform. It's important to have a good namespace, a good taxonomy for metrics, so we can make sense of them when we receive them, when we analyze them. And we can have, with StatsD, we can have two types of events. One is just a counter, so we count how many times a certain event happens, or we can time information. So we have like how long it took to do a certain service call or a database query. So we can then collect all this timing information, and we can collect aggregate data, averages, and normalized data. And the output on Graphite is something like this. So you have bidimensional graph. You can plot those lines across time. You can combine many metrics. You can overlap them. You can have a line view or a stacked view. So it's really, really easy to get started. How much time do I still have? I forgot to start the timer. Because if I have still have like 15 minutes, I'll just go on a diversion. OK, I think we have time. I just want to make a note about what we collect, because we usually collect wrong parameters. We look at averages as the only metric that is important to our system. It doesn't matter what kind of unit we are looking for, if we're looking at bandwidth, number of requests, latency. We usually just look at the average. So it's one number. What we should look at is the distribution instead. We are probably familiar with a shape that is like that. It's called the bell curve, bell distribution. And instead of just one point, which is the middle line, the average, we should think about three areas. So one is the central part, that is contained within one standard deviation of the norm. And then we can consider a larger part, which is two times the standard deviation. And everything outside these is probably going to be errors or anomalies, right? Why am I mentioning the bell curve? Well, because we think it represents the shape of any kind of event. And it's not correct. Especially for web traffic, the curve is more like that one. So it's not a curve with a central point which is higher than the rest. It's not bell-shaped, but it's usually higher. So there is 10–20% of requests that are resolved very quickly, and those are either cached requests or failures. So you have very fast responses. And then you have a longer tail of the distribution of the other responses follows a longer tail. So you can see that the average, the green line in the middle, is not the same as the median, right? So this would be a mistake to confuse the two, because it would give a distorted view of what's happening. So averages don't give the full idea, right? So that's what we have usually, just one line with the average. It would be much more useful to look at the distribution and the percentiles. So you look how many of the requests are resolved within 50 milliseconds, how many are resolved within 100 milliseconds, and so on. So you look at the 50th percentile to see the majority of requests resolved within a certain band. And these are much better. Especially the 50th percentile is really good because it's less spiky than the average usually. And it's easier to put a static threshold on that and alert if there is a big variation in the 50th percentile. I mentioned earlier how good our brain is at detecting patterns, so I'm going to show a few shapes that evoke emotions and we can use to recognize things. I already mentioned this, the need to create baselines and to normalize the data. As I said, a big, scary picture like that can evoke certain emotions. But if we look at the units, then we can realize that if we normalize the data, it would be very different. Always remember to set a baseline, because that's what you compare, right? If you don't have a baseline there in the graph, you constantly have to look up the baseline somewhere else. So you have to engage your attention. You look at the graph on one side, and then you have to look up the baseline on another one, and then you have to compute whether you're still within your tolerance level or not. I'll add something more. You should let the computers calculate the baseline, because the computers are good. We made a huge progress with machine learning. We can let computers understand shapes, so we can let them model what the correct shape of our traffic is, right? Of course, not all metrics can have a linear threshold, because if we think about the average website, it will have a kind of traffic that varies on a daily basis, hour by hour. So for instance, an e-commerce site that is regional will have a lot of traffic, maybe in the morning, midday, and then almost nothing at night. So we have a shape that varies a lot over time, but it's still fine, right? So you would really need some kind of tool that is able to draw a snake-like shape all around that pattern, and recognize as normal everything that is within that snake, and detect anomalies, everything that is outside this band. Luckily, with the Graphite, it's just a matter of applying one single function to your metric. You just apply the derivative, and it will flatten your graph, so you can have a linear band and consider everything outside that band as an anomaly. So it's really, really easy. As I showed earlier, it's good to have different ways of representing information and different views of the same data. I bet if you look at this graph, almost nobody will notice there is a problem in there. If you look hard, one node went down, right? But with stacked view, all nodes will automatically rebalance themselves to take on the traffic that was formerly taken by the node. And if we use the same graph, but with stacked lines instead, it's much easier to spot the same problem, right? Another pattern you might have recognized is when we see some kind of capping at one end, usually the higher end, and this is probably a pattern you've seen if you ever did any kind of audio editing. So there is like a saturation of the band, and everything is clipped. And this is a signal of things that are either resources that are used up completely, or the flow has been discontinued somehow. There are other anomalies that are easy to spot just by looking at graphs. If you learn how to look at certain shapes, like this one, you see some regular event that happens daily at the same time. When this happens, always check your cron jobs. I bet 99% of the times they are the cause of the problem. As a last example, I want to combine all the information we gathered so far in this talk and show you a great way of creating really visually compelling dashboards that are really, really intuitive and easy to understand. And they are heat maps. You're probably familiar with heat maps because they are used either in eye tracking systems to see whether the attention is focusing on a certain web page where the eyes are pointing to on the web page. Or we can see all kinds of infographics showing the density of population in a certain area with different colors. But there are other types of heat maps that are really useful, right? I showed you one earlier with the green bars that represent everything is fine during a time period, or red bars when everything is not fine. And there are tools that can apply heat maps to your network layer. So for instance, this is an image of our set of routers and switches in our infrastructure. And you can see the bandwidth across any two of those switches at any given point in time. So we connected the data coming from Graphite from Ganglia to this visual representation. We call it rib cage because it visually reminds us of rib cage. And as soon as there is like a saturation of traffic or traffic becomes higher on one link, that link will become red or amber before it becomes red. This is our new switch infrastructure. We upgraded everything to 40 gigabit links, but it's the same concept. And yet, this is not enough, because this is, again, out of context. You should add context to this information. Bandwidth alone doesn't tell which part of the system is overloaded, right? So we can use a different approach. I'm sure most of you already use Cacti or a similar tool to collect system information like bandwidth, CPU load, and memory load. There is a plugin written in PHP called the Weather Map that can display the information anywhere you want, anywhere you want. So you can have like a background image and then create your flow of information and connect every single arrow to data that is produced live in Graphite or another system. So this is what we did, for instance. This is in the background, we see the architecture of a system, and we simply draw some lines to indicate the bandwidth between any two parts of our inner infrastructure. So we can see whether there is one hot link down there, something red. So that component is overloaded. And a 5-year-old can look at that image and see there is something wrong there. You don't need to engage your attention to read data, read graphs. You can see, right, immediately. And you can have different kind of metrics there, right? So you can monitor bandwidth, you can monitor load, you can monitor overload in a certain component, slow DB queries, you can even monitor disk space, anything you want. Anything that you can collect data from, you can push it to this system, and you will see the image and the colors change live with your application. And it's super easy to understand, right? So before ending this talk, I just want to conclude with a few reminders of what we talked so far. Always try to make the information that is hidden stand out. Make it obvious. Make everything that is complex simple, because our brain likes simple things. And avoid busy dashboards. Make them clean. The information can speak for itself. Group data by context, not by means of production, not by the tool used to produce the data, but give it a meaning for the users, for us. Also, try and detect anomalies by having all sort of alerts and thresholds that can be dynamic or can be, as I said, can be made linear by just playing a few tricks. Give all the numbers a visual shape, because our brain, the most developed part of our brain is the visual cortex. We can process a huge amount of information if it's presented in image form. The cortex is a recent part of our brain. So we don't have the same capacity of processing the same amount of data in there. And finally, I think I made my case. Appeal to your intuition and conserve your attention. I'll leave you some references. As I said, the Daniel Kahneman book is a great start, but there are other links. We're hiring if you want to play with the Twitter fire hose and 15,000 messages per second. Any questions? Oh, by the way, that's my email address and my Twitter account. I would appreciate any kind of feedback. And I will publish the slides at that address. Yes?
Hi, thank you. And I'm interested in automated anomalies detection.
Yeah.
So there was a graph showing spots where cron jobs were running.
Yes.
In your presentation. Do you have any tools or
too much.
I think the very next one, or maybe
that one.
Sure. Oh yeah. So what do you do with that metric? How do you?
Well, this is an example of an anomaly, maybe on system load, that has some spikes during the day.
Yes. Okay. But
yeah.
Let's say I have 4,000 of such metrics, and I want to automate the process of anomalies detection.
Yeah.
That will take into account that there are cron jobs, but I don't want to do any manual actions. Do you have any tools?
Yeah, so this graph will not automate the discovery problem. Will merely highlight the presence of a problem.
Okay.
So once your attention is engaged, once you know there is a problem, then yes, you look at the other graph, you look at the other data, and analyze the problem. But the monitoring dashboard is not for that. It's not for analysis. It's just to alert you when things go bad, right? So I would say there is an automated tool that can do that part of the job as well. There are tools that help, that go a long way in refining the scope and limiting the spread of the problem to a very specific narrow area. But human judgment at that point is paramount. You can't replace that, not anytime soon. You can probably go that way just by applying some machine learning to the data and let those algorithms learn good conditions from bad conditions, and again create alerts on things that you weren't looking for specifically. So you give the machine again all the data to analyze, and you let the machine, you train the machine to say, okay, this is wrong. So anytime you see a pattern that is similar, please trigger an alert, right? So you can train these algorithms to detect wrong patterns.
Thank you.
Okay. Other questions? Anyone? Yep.
What would be the best practices in the user experience to give them choice of the time frame they want to see the data in? Are there any tricks that you would recommend instead of just having a button like the last day, last 2 days, last week, or something like that?
Well, all these tools, usually like a Graphite or the dashboarding tool, visual tools to run metrics, let you define the time interval. I showed you a slide earlier on that showed.
I'm sorry, it's
sorry.
like not for an admin. It's a dashboard for a user that we don't want to familiarize the user with a new tool, and probably we can't even show the Graphite to many users, like as in front end. But
well, when I talk about users, I talk about DevOps, the system administrator that are the recipient of this kind of information.
Okay.
There are all sorts of dashboards. You have business dashboards, you have analytic dashboards. This is about monitoring dashboards. So I wouldn't show any of these metrics to the end user and the consumer of your product, unless you're a metric company. You can simplify the information if you want to show like the SLA or the average latency of your system to the end user. You can have like a status page showing like a green bar, hour by hour for the last day by day for the last week, and then week by week for the last month. So you can have different windows. So you usually give more space to recent events, and then you aggregate data more and more as time passes by. So that's something you can display to end users as well, because it's simple information. You can have different granularity. Does that answer the question?
And could you give any references about good practices in visualizing data rather than only the book about thinking and intuition? Do you have any sort of books that you would recommend for this topic?
There are not many tools. I think Riemann is a modern tool that helps create.
A book like for.
Oh well, there are
understanding
plenty.
the topic
There are
of-
plenty. I think Stephen Few is one of the authors that focus on visual dashboards, and all his books are really good. Edward Tufte is also a professor of, that wrote a lot of books on how to display information, also really good. And any book about cognitive science, like Daniel Kahneman, Thinking Fast and Slow, or books by Dan Ariely, like what's it called? Predictably Irrational. They put you in a certain mentality to think about how our brain is processing information. So you can then apply the same principles to a different field. Maybe the study was done on a different topic, like economics. But as I showed you, it's very, very, very easy to port those concepts to a different domain, because the brain works in the same way across domains.
Okay. And do you do A/B testing in designing your graphs?
In a way, yeah. So we don't have the large scale that traditional A/B testing provides, because again, the intended users for these kind of dashboards are sysadmins. So we only have like 5, 6 of them. So the representativity would be pretty small. But we can ask them, do you think this information is immediately, or do you think you're finding yourself spending a lot of time looking at information just to make sense of it? Would you like to try something different that is more intuitive? So you can just glance at the graph, see that everything is fine, and carry on with your work. So you just talk to them, you ask, is this working? You try something else.
Sure, thanks.